All right, so good evening, everybody. Welcome to this week's TWED Talk. Today it's Evan Patton. He's going to be taking us through some industrial strength semantic web application building using Java servlets. It's going to be very interactive. Evan is going to just give a few minutes of overview from PowerPoint, and then he's going to dive right into code. I know some of you may have the VirtualBox set up, others just follow along, and good times. And just to advertise, in a couple weeks, Evan is going to return at the end of April, right? The last week.
24th, yep.
The 24th of April. Evan has volunteered to do another talk on using MIT's App Inventor to create Android apps, semantic web Android apps, which should be another exciting time. So take it away, Evan.
Yeah, that's all in the pipeline. We're still developing it. It doesn't quite work. Well, it does work, but very basic. So anyway, for this talk again, I'll be presenting how to build some basic semantic web applications using Java servlets. And basically, I want there to be three things that you can take away from this. First is we're going to learn some of the basics of Java servlets, and actually, for the most part, a lot of you, when you go out and if you do build Java-based applications, you're probably going to use an actual framework for this. But I thought it would be nice to kind of go through some of the basic stuff and not deal with all the heavyweight frameworks that are out there, because that would just add a whole additional layer that we'd have to go through. The second is that we're going to do a little bit of configuration with Jenna and Pellet, so you guys can all see how you can use those in your applications to provide access to RDF data and then reasoning about data that happen to be encoded with OWL. And then we're going to actually look at two different mechanisms for accessing data. The first is going to be tag libraries, which allow you to actually reference your Java code inside of what's called the Java servlet page. And then also we're going to provide an API essentially where you can make a call and get an array back of data. And we're going to go over those in a minute. The first one, in the first half of the talk, and then the API towards the end. So this is the work environment. You all should have received an email if you're on the Titleist list about this. We're going to be using VirtualBox. Of course, if you do have your system set up with Eclipse and Tomcat and all that, you can just use that stuff. If not, you can download the image. And this is wrong. There should be a .bz2 at the end of this, but that's in the email. And then just for your reference, if you ever need to do anything with root access, your password is TWED. Nice and easy to remember. So I just tried to gauge before we started, and it seemed like everybody who is going to be following along has already either set up VirtualBox or has set up Eclipse and knows how to use Eclipse on their machine. So I will skip going over VM setup. Well, actually, why don't we do it anyway? I'll go through the prompts that when I complete it. But the first thing you would do is you come into VirtualBox here, and you would click on New to start a new virtual machine. You can call it whatever you like. I called mine SW servlet _TWED, so you can just go crazy guy speaking. And then you could go in, we're using Linux, obviously, because I don't want to pay for a Windows license. And you would hit continue. I've given myself about 1.5 megabytes in my image. You should adjust based on your machine specs and how many other things you have open. Basically, 1.5 gigs is about what I'm going to get out of this machine with everything closed, unfortunately. So you would set your RAM in here, how much you want to give, and it gives you this nice little scale here to try to give you an estimate of where things might cause problems. Green obviously being good and red being bad. The next step after that is you will want to do the hard drive, and so in the email, if you downloaded the link I sent and uncompressed it, you would get the BDI file. And then what you would do here is you would select to use an existing virtual hard drive. and come over and click on this little folder icon with an up arrow. That will open up a window where you can go and you can browse your file system. At this point, you would find that VDI file and select it and hit open. And then you would hit create, and that would finish the process. The only other thing that you may need to set up is the networking. So I'm going to be querying the wine agent ontology from the wine agent server, and so you'll need to have networking support for that. Basically, if you hit the settings button on your virtual machine, you go into network. You see we have bridge adapter here. I'm going to switch it to Wi-Fi because I'm on the Wi-Fi right now. And you would select the appropriate connection for your machine. So on the Linux box, it might be ETH0 or ETH1. On Macs, it's N0 or N1. And I have no idea what it is for Windows. So you would just pick what's appropriate there and hit OK. And then when it starts, it should connect to the wireless and get an IP address and all that lovely stuff. And we'll see how long the wireless will last with twice as many machines on it. And once you're all set here, you should just be able to hit start, and it will launch the virtual machine. And then we will take the time to let it boot. In the meantime, let me talk a little bit about what we're going to kind of focus on. So the idea that we're going to explore today with this is we're going to try to use the wine agent ontology to kind of make a little basic user interface to describe a class of wines and then use subsumption reasoning to figure out similar wine classes. And by similar, what we're actually looking at is wine classes that are more specific in their selection, if you will, than the class we actually generate. And so the idea here is that if you specify something and you say, well, I like medium-bodied red wines, it could suggest different wine classes that are medium-bodied red wines, but also have more specific properties, such as having a strong flavor or being made from Sauvignon or something like that, Cabernet Sauvignon. So that's kind of the kind of general flow of this. So we're going to use the tag libraries to help with generating the user interface, because that allows us to reference our Java code as part of our page. And then in the second half, to actually do the reasoning component, we're going to provide just a regular method that you can call via HTTP GET and use that to actually perform the inferencing step. And Jim just stepped out, but earlier Jim and I were talking about Sadie. So Sadie has a Java library that you can use to help you with handling a lot of that API-related stuff to doing the reasoning component of this. So you could potentially substitute that in at one point, but we won't be covering that today. So once you have your VirtualBox loaded, and it's still taking its time here, I want the menu. There we go. You're going to come in. It's got a kind of a little start menu, so they call it the kickoff launcher, but for most of you, if you're using Windows, it'll be the start menu. And then come up, and you're going to want to start Eclipse. And Eclipse is going to kind of be our environment for doing all the work today. We're going to configure our project in here. We're going to set up a reference to a Tomcat server where we're going to be running our code and testing it out. And then also, if we run into any problems and it crashes, we'll get to find out kind of where it crashed, but hopefully that shouldn't happen because I've already done it. And then at the very end, you'll basically get to say, hey, I built a servlet kind of from scratch. So we're going to pop into the workbench here. And then the first thing you're probably going to want to do, I tend to change perspective, so I'm going to switch into Java EE here. If you're comfortable with any one of these perspectives and you prefer that, then you can, like most people, probably use Java, not Java EE, but since we're building a web archive, I'm going to use Java EE. And of course, if you want to follow along just as I'm doing the prompts here, then it should be exactly the same. So next step, we're going to come in here, we're going to go up to the File menu, and then we're going to say New Dynamic Web Project. And so there are a number of different types of projects, and Dynamic Web here is just going to be a basic servlet project. And then you can give it a name. I call mine Wine Servlet. And again, you should be able to call whatever you want. The reference project at the very end, well, it's called Wine Servlet, so you can, if you name it the same, you shouldn't have any issues there. Next thing is you want to hit New Runtime. This is basically where we're going to tell it which servlet container we're planning to build for. And so what we're going to use is we're going to use Tomcat version 7. And then you want to kind of come down here, and it has this checkbox, create new local server. You're going to want to check that, and then hit next. The next thing it's going to ask you for is what the installation directory of this is. And as part of the image, I've already set it up for you. So you would come in and you click Browse. And then in your home directory, which is tetherless, there's this Tomcat directory. You jump into Tomcat, and then you should just be able to hit OK. And just make sure there are no errors up here. If you've selected the wrong directory, it will say it can't find the right Tomcat version. But if you're in this Tomcat directory, you'll see exactly what we see up here, where we don't have any errors. And then once you've got all that, you should just be able to hit finish. And so this will set that now. So now we see before we had none in this target runtime, and now we see that we have Apache Tomcat version 7. For dynamic web module version, this is 3.0. If you're familiar with the Java servlet specifications, you know that this is the latest version is 3.0. There's also 2.4 and 2.5, which are pretty well deployed. 3.0 adds a number of new features. We won't actually be using any of them today, but it's always good to be forward. We're going to hit next at this point. It's going to say, what are your source folders going to look like? If you were using an alternate build system like Ant or Maven, where you have a different directory structure, you would supply it here. But for what we're working on, we're just going to take the defaults. And then again, this allows you to kind of customize. Context root is what the name will be in the URL when we deploy it. Content directory is where we're going to put all of our web content. So this is where you put images and CSS and JavaScript and all of those different resources. And then one thing we will be using from Servlet 3.0 is we don't have to generate this web.xml. We can use annotations, and I'll show you how to do that. So that is one nice convenient feature. So I'll hit finish at this point and leave that as the default. Now you'll see we have this nice little Wine Servlet project here. And you can expand this out, and you may get errors. They've never actually caused me any problems. It might be something to do with the way Eclipse was configured when I installed it from apt. And probably because I installed it as root and I'm running it as non-root and it's fussing. But Java resources, you'll see the source directory that we had the option of configuring. You'll see our web content directory. Here you've got meta-inf and webinf. And webinf is where we're going to be putting our libraries in a moment. And so let's start. The first thing I want to do here is I want to come into my source, and I'm going to start with a hello world. Just like every class you've ever been in, there's going to be a hello world. So we're going to come in and do a package, and I'm going to call it edu.rpi.tw.reasoning. And when we go to all the sample code, it's going to use this package, so you may use it. You can also change it if you want. Like if you have a project you want to work on at some point, maybe you want to set the package to that. You'll have to adjust appropriately. So we're going to hit finish. You'll see now we have an empty package on the left-hand side there. And then I am going to be cheaty, and I'm going to come over here go to Computer, go to Home. And I've supplied all the samples here, so for instead of you having to type out hundreds of lines worth of code, you can just copy and paste, and all of that is in Documents. And then for those of you who are following along and are doing it on your machines, this zip file here was also contained in that email, and this contains all the code in this folder, so you can use that for your reference. And then coming to step 1. And the first thing we're going to do is we're going to take this wineservlet.java, and I'm just going to copy it, and then come over here and paste it. And if we open it up, you can see it's very, very basic. I mean, we're just trying to start off. You'll see all your imports. The important thing here for this is to recognize this web servlet annotation. For those of you who've done web servlets in the past, prior to 3.0, you're used to having to build a web.xml or having your compiler generate a web.xml for you. Here you can actually specify all of the contents of that XML file as annotations, and then the servlet container will actually read those in at runtime, and you can do this instead of using the XML deployer. Of course, that means you can only run it in servlet 3.0 containers. So you couldn't take this, for example, and run it in Tomcat 6 because it would fail. So this is our basic servlet, and we're going to come back to this in a few minutes. The next file you're going to want to copy over is this index.jsp, and you're going to put this into your web content folder, so that it resides here underneath webin. And if you want to open this up, it's just say basic JSP file, and other than this line here, you'll all recognize this as standard XHTML. And then it's just simply going to say hello world. Okay. The next thing, just to make sure that this is working and we have a nice little sanity check, you can come over to your wine servlet, then come up to the toolbar here and come to run. Then you're going to say run as, and then run on server. And it's going to ask you to which server do you want to use. We're going to say choose an existing server. You should see the Tomcat server that we defined earlier showing up here. It'll say stopped. And then just for convenience sake, we're going to say always use this server for this project. There could be other resources on this. We haven't set those up, but if you're not following along with the virtual machine, you might have other options in here. Just make sure that wine servlet is on the right-hand side. And so what it's going to do is it's going to go through and it's going to build, and then it will pop open a little web browser, and then you should see hello world. Okay? Anybody not get hello world? Okay? All right, great. So step 1 complete. But there are some important things here, right? Now we've got a servlet, now we've got JSP. This is going to kind of be the platform we're going to build off of to add all of our features now. So if you go back to your Explorer window, there's a step 2 directory. And this is where we're going to start playing around with domain. And I'm going to define this domain model object. It's going to kind of encapsulate all the interactions with our ontology. And there's also, you'll see this libs folder here. This is where you're going to find all of the libraries necessary for running Jenna and running Pellet inside of this application. So you're going to want to come in and select all those, and then hit copy, pop over into your webinf, and then underneath there you should have this directory called lib. If you don't, make sure to create it, but it should have been created by default when we created the project. And then you're going to paste all those libraries in there, and then Eclipse might freak out at you. And then if you come under libraries, under resources, you'll see there's this web apps libraries. And then if you open this, you'll see these are all the libraries we copied. So this is basically Eclipse confirming to us that these libraries are going to be on the build and the runtime path for this servlet. which is important because if they weren't there, then it wouldn't work. Then the next file, you're just going to go back up here and copy over the domain model, and we're actually going to create a new package for that. So if you come over here, you can go new package, just like we did to create the first one. And I'm going to call it model. At least I expect I'm going to call it model, and we're going to paste in there. Now we're going to just take a quick look at that. Let me make that bigger. And so I'm just going to briefly go through some of this and try to explain to you a little bit about what it's doing. So the first thing here, for convenience later, in terms of making the UI look at least a little bit nice, I defined this comparator for individuals. An individual in the Jenna framework is essentially an instance. It's not a class, it's not a property, it's an instance. So like, if I had a URI representing me or representing the camera, for example, then I would add properties to it. And the idea here is we're just going to use this to sort instances alphabetically by their labels. And that, again, that's just mostly to make it convenient to use, because otherwise things come back in whatever order the hash table has them in, and it doesn't really look good. The second thing we do is I had this reference to an ONT model, which in Jenna is an ontology model, basically a model that is backed by a reasoning engine at some point, or at least contains ontologies. Then I have an initialization method. I set some basic options in Pellet, mostly to just try to improve the performance of the classification. And the next step here is that Jenna has this object called the model factory, which is responsible for creating models for you. You tell it that you want to create an ontology model, and then you specify, in our case, we're specifying the Pellet Reasoner Factory spec, which basically tells Jenna that we're going to use Pellet to back this reasoning model. Jenna has a number of specifications as well. It can do various levels of OWL and RDFS, and it uses a rule-based engine to accomplish that. So. Then the last bit here is that we simply read in our ontologies. So I'm reading in the food and the wine ontologies from the wine engine. And of course, you could take those, for example, I won't do this, but you could take those and load them into Protege, right? Yes.
Is the wine ontology that important to the food ontology?
In our version, it doesn't. In the one on the wine engine, it doesn't, because in the server version there, I've done a little magic with having to deal with we have an agent ontology and a few other things. And so sometimes I only want to import one or the other and not have them both together. Okay. So here I'm loading them like this. But yes, if you had a copy where you did have OWL imports, Pellet would just pull it right in for you. But the way we have it set right now, that's not the case. But the agent takes care of doing all that for us, so it kind of hides that. This is just a simple helper method. For those of you who have taken a software engineering course, you probably recognize this as basically the singleton method. Where we're basically providing one single copy of the model for everybody to use, and that one reference is returned by get here. And lastly, a destroy method for cleaning up your resources. You should always clean up, especially when you're dealing with potentially large data sets in Java, so you can let the garbage collector do its job. So this next method here, this next method here, I called it get back to cardinality, and we're going to use this to determine what the cardinality of a property is, and use that to actually control the type of rendering that we do. So for a situation where we have a max cardinality of 1, we're going to present a regular kind of drop-down select box. If we have an opportunity where there's more than 1, we're going to present a list where the user can select multiple items. And then basically this computes that. It goes through, given a class and a property URI, pulls those objects out of the model, lists the superclasses of the class to look for OWL restrictions or intersections and the like, and basically crawls the list of superclasses looking for max cardinality restrictions and cardinality restrictions, and then uses those to basically compute what the max cardinality is and returns it. Then the next method we have here, actually I'll come back to because I want to present this method first, which relies on it, is get values for property. So once we have our class and our property, we're also going to want to actually be able to present the user a useful set of items to choose from. I mean, we could present everything in the ontology, but most of those things aren't going to be relevant to the property. And so we follow a similar kind of pattern here where we get, given the URIs, get a reference to the class and the property, and then we list the superclasses again, find restrictions, but in this case we look for all values from restrictions. And then we also grab the range of the property and throw that into the mix as well. Technically, that's not how the RUFS rules work, but we're going to use it for convenience here, and in fact it shouldn't affect the reasoning at all. You can probably take that line out. Once we have all those classes, we use this helper method, which we'll talk about in a second, get items in intersection, where we basically give it the set of classes, say, okay, tell me all of the items that you know of that would exist in all of these classes, right? And then simply we're going to sort that and send it back to the client. And that magic happens in this function, which I skipped over, which again is pretty straightforward. It's just computing an intersection. One thing you could do instead of this is you could, for example, construct the intersection class and then ask Jenna or Appella to actually give you all of those. So this is more of a naive implementation. It's possible that in constructing that class you will eliminate additional values, but we don't really consider that here.
So why are you doing it that way?
Mostly because I think it's easier for people to follow code-wise for the explanation. Yes, and we'll actually, in the second half of this, I'll show how you would do the intersection version. Not of this particular one, but for the purpose of constructing the class to find its subsumed classes. Okay. Now, the next thing, if we go back here, that's basically going to provide us the interface for exploring our model a little bit. The next thing we're going to want to do is if you come here and you go to step 3, we're going to add a bunch of new features. So the first thing you're going to want to pull in here is wine.tld. And this is going to end up going into the webinf directory. And a TLD file is basically a tag library descriptor. And if we open it up, you'll see that we basically, you can define, give it kind of a name what this tag library is meant to do. So I called it the wine TLD. Then you can define any number of tags. So I'm defining a tag called prop picker. You reference specifically the fully qualified class name, what the class is going to handle, a reference to this tag in the code. We specify that it has an empty body, so we shouldn't see an open tag, some text in a closed tag, for example. We want it to enforce that there's going to be no content inside of it. And then you can define a number of attributes on the tag and whether those things are required and what their types are. And so here we have 3 attributes, name, class, and property. You'll see that I use class with 2 Z's because class with 2 S's is a restricted keyword in Java, so we can't actually use class. So we're going to use class instead. Then the next thing is we're going to pull in that prop picker class. So come out and copy that, and then pop back into Eclipse. Then we're going to do a new package. View RPI TW reasoning taglib. So this package is going to be under that reasoning package again. We're going to call this taglib. And then once you have that package, you can go ahead and add the class to it. And if we open this up, you'll see how we implemented this. The first thing is that it needs to extend the class called tag support, which basically provides you a lot of helper functions that will simplify writing the tag. There's a higher level class you can implement, but it's usually not worth your time to do so. It's usually easier to just extend this. We define properties that we have. You have to provide setters for those. The idea being is that the servlet container can't just come in and write to your private variable, so you provide a setter for each variable, and then it will call the setter appropriately. And then lastly, we have the actual body of the tag, which is in this doStartTag method. And the idea here is when this tag is encountered in your file, it will create one of these tag instances of prop picker, and then it will call this doStartTag method. We have page context. The page context comes from the tag support, and basically it encapsulates the current state in the file where this thing is being evaluated. And one of the things you can do, we haven't done it here, but you could probably build a more complicated tag library if you wanted, where you could add additional properties to it. So for example, maybe you wanted to have a namespace tag where you define all your namespaces. You could set properties on this context that could be used later on in the page. So you can use that for doing sharing of resources between tags, for example. We make use of our domain model object that we went through a few minutes ago. We get the max cardinality. And then using that, we start building a select element, and we basically say, well, if the max card is 0, meaning that you can't have any instances of a property on it, we just will disable that element. If it's max cardinality greater than 1, then we'll state that it's multiple, right, so that you can select multiple items. And otherwise, it would be 1, in which case we would just say that we're going to put an option where you might have, it could be up to 1. Similarly, maybe you could add a get main cardinality, where if the main cardinality was 1, you could enforce that it had to not be empty. So you can see how if you extend the domain model object, you can start adding some additional complexity in here. And if you're interested, maybe we can do that at the end. The next thing that we do is we use that get values for property helper that's going to return us a list of individuals, which we then use to populate the values in that select object. And then once we've done all that, we cut in and we just write it out. If in the event for some strange reason your user has closed the browser prior to this executing, you'll get this IO exception, so that's just caught to handle that. And then lastly, you have to return kind of an action to handle. So in this case, we say skip body because we're not interested in the body. You could actually have it continue and process the body, but for our case, that's not important. So that will actually provide us something useful. The next step is to actually use it. So if you come in here, and I'm going to open this up in text editor, because it's actually just a subset of the file, and we're going to merge it in. So the first thing you want to do is to define a taglib in your JSP. You use this taglib element, and you specify the URI of the tag library descriptor, and you assign it a prefix. So we are referencing the wine.tld in webinf, and we're going to reference it by wine. And then what we'll do is we're going to add a form essentially into our index.jsp, where we're going to reference that prop picker we've defined we're going to tell it, here's the name of the element we're creating, here's the class that we're going to be using to control the kind of the cardinality of the property, and then the property itself, where we're going to use the combination of the class and the property to figure out what the set of values are that are relevant to that property. So if we come in here, I'm just going to open up my index.jsp. I'm going to add in that taglet entry, and then I'm going to pop out here, grab the form, and replace my hello world paragraph with a copy of the form. And so here we're going to provide two different things. I've provided wine color and grapes, and similarly you could copy and paste this to do flavor, body, and sugar, which are the four we primarily use in the wine agent. And then we're going to come in here. There's one last kind of maintenance thing which I didn't talk about, but because we're doing this domain model and because it's got a static object stored inside of it, one of the things that I wanted to do is make sure that we include appropriate methods to initialize it at the beginning when we start the servlet and then destroy it at the end. So for example, if you are doing a lot of deployments while you're developing, the servlet container often has a lot of trouble clearing out class loaders where you have static items because they hold cyclical references. And because of that, if you don't do something like this, where we go and we set the models to null, all these things stay in memory and can start to consume a lot of memory. So this is kind of meant to help with the memory management aspect of this. So if you take that code, pop into the wine servlet and just add it in there. And then I have the imports that are necessary for this. That will basically just help us with memory management. Now, if we come to index.jsp and come up and we say run again, let me help that out so we can see the console. Might have to stop this, I'm sorry. And then come back to our little web browser. If you still have this open, if you don't have it open, you can open it, for example, in Firefox. The path is going to be localhost :8080/wine-servlet. And we're going to load that up again. And then if you have Eclipse open, you'll start to see this is output from Pellet as it's going through classifying the ontology and trying to figure out what classes are related to what and what instances are related to what. It's going through all that. And we're processing results in the middle, and you'll see every once in a while a bunch of URIs pop out, which are going to be used to populate our user interface in a second. And so that comes through. It's not the fastest thing in the world, but for what we're trying to do, it will work. And then at the end of that, you get your little form. We have our wine color, we have our grapes list. If you come into wine color and you drop it down, you'll see that you have the choice of red, rosé, or white, which are the three wine colors defined in the ontology. And then you'll also, if you scroll through the list of grapes, you'll see all of the various grapes that we have represented in the ontology. And so that is how all of this comes together, right? So we've gone through, we've found our class, we found our properties, we found the relationship between the class and its cardinality via the property, the relationship between the class and the property, and the range of values that that property can take on with that class. And we are able to build up this little form. And of course, with that property picker now, you could, again, go and add additional features in here without having to write really any additional code. Reuse that one tag. Okay. So this really isn't useful right now because all it does is render data, it doesn't actually consume it yet. So the next step is that we're going to add a little bit of an API here where we're basically going to do some basic subsumption reasoning to figure out if we pick a color and a grape, or just a color, what classes are related to it. And so to do that, we're going to go out here and step up to step 4. And I'm adding a new class here called subsumption step, which is going to be responsible for doing our reasoning. And we're going to add that along to the domain model into the model section. Let's take a look inside that. So what I'm doing in this is I'm going to store references, primarily for convenience, up to the color that we get from the client and the list of grapes, if any, that was selected by the user. I've stored references to the food and wine namespaces here, again, mostly to simplify the code further on down. And then in the constructor of this class, I'm basically going to accept the request from the client, pull out the color property that was selected, and then pull out grapes if they exist. If they don't exist, I'm going to create an empty array. And that's just mostly to keep the code below a little bit kosher. And this is where all the reasoning is going to happen, where we're going to infer the subsumptions using pellet. So we get a copy of the model from the domain model object. We get a reference to the wine class, a reference to the has color property, and a reference to the made from grape property. Then we're going to build up a set of restrictions. We're essentially going to say, because we're going to use this to create an intersection further on down here. So in the set of restrictions, we're going to add that it has to be a subclass of wine. It has to have the color, and we get a reference to the resource, which is named by whatever URI comes in as the color. And then again, for every URI in the list of grapes, state that it has to be or has value restriction on made from grape, stating that it's made from the specific grape. We have that list now, so what we do is we can create an intersection class in the model where we have to do this little decoration where we create a list, and that list is constructed from an iterator. So we pass in the iterator, it creates an RDF list. So this is a little syntactic sugar. If you've ever actually looked at an RDF list by hand in triple form, you'll see that you get that you have a blank node, RDF first, your first item, RDF rest, another blank node, RDF first, RDF rest, and so on and so forth. And this, rather than having to go through that process of creating that linked list, this is a little helper that you can use to simplify that process greatly. Those feed into the intersection, so we basically now have a class that represents the intersection of all those classes. The next step is once we have that class, we can ask the model to list all of the subclasses of it. And this is where the Tableau algorithm kicks in. So you provide it a description. You pick a color, you pick a grape, or maybe you don't pick a grape, or whatever. And then using that description, it will reason about, let's say there's a variable x, instantiate x as a member of this class. Will x always be a member of that other class, right? And it will do this for every pairwise case, although there are optimizations in there. So that's kind of like the naive version of it. But it is that if you create, suppose that I have a variable x and it's a member of this class, is it also a member of this other class? And so you can do that little thought experiment yourself. That gives us a list back of all of these substudent classes, and then we basically just build up a response. So while we have, we get an iterator, and we iterate over this, and we simply say, get the next item, and we do two checks. First, we check that they're not equivalent, because in theory, any class subsumes itself because they're equivalent. It's equivalent to itself. And then we also get the URI because owl nothing subsumes everything, because the empty set is a subset of everything. And so we just filter out owl nothing. If you didn't have this line in here, you would also see owl nothing as a potential option, which is true, but is not really useful for the purposes of any application we probably want to build based on this simple API. And we just build up a set and then do a little bit of cleanup, because again, we have this copy of the model. It's shared across all of the objects in the space. So we clean up by removing this blank node that we've created, along with all the restrictions that we've created to generate it. So that's just a cleanup operation. Otherwise, your model will continue to accumulate all of these intersections that people build, and eventually you'd run out of memory. So that's how the subsumption step works. Now if we flip over, you'll see that there's another wine servlet. And I'm going to close the hold on here. We're going to open that with our text editor. Again, it just contains the relevant pieces that we need for this next step. One thing we're going to add is we're going to add to the annotation on this class that we are adding a URL pattern. And so a URL pattern tells the servlet container, it says, I will potentially be receiving requests at URIs that match this string. Those don't necessarily exist in the file system. So if it doesn't exist, then call me and I will try to handle it, right? At a very high level. And obviously there's a lot of error checking and other things that go into that. And that happens in what's we're going to do here is define a do-get method. So the HTTP servlet that we're extending, that we talked about at the very beginning, actually provides some, did I not copy you? All right, we'll take care of that in a second. But anyway, so the servlet here, this HTTP servlet, understands the verbs in the HTTP protocol. And so it actually provides all these different methods, do get, do post, do put, to handle the relevant verb in the HTTP protocol. Yes. And so we're just going to assume get, and if you if you were looking here when we took it before, I primarily focused on the two property pickers, but if you look here, we specify that it's going to be a get. If you needed to do post for, say you were uploading a picture and you wanted to attach annotations to the picture, that would be a situation where you'd override the do post rather than do get. So basically, what we're going to do is it's pretty straightforward because all the other logic has been handled in the other classes. We instantiate one of these new subsumption step objects. We get the set of classes from that using the logic we just went through. And then I get a print stream that basically wraps the output stream. If you're familiar with Java, or even if you're not familiar with Java, but if you're familiar with Java, you know that output streams only take arrays of bytes. And so for convenience sake, we wrap it in a print stream, which allows us to manipulate strings and ints and all the other stuff that you're used to trying to print, and you're not usually printing just arrays of bytes. And then we simply can just tell it to print out as a, with a line return our set. And the set class takes care of making it look pretty. Now, if we do all that, I'm just going to come out here and stop our server, and then I'm going to start it again. Now we can come in, and let's say we just wanted to think about red wines. So I'm going to select red, and then I'm going to hit submit. And then we should see any second now. Yep, there it goes. Pellet starts thinking about what classes subsume a wine that has the color red. That's the general high-level description. And then our data comes back to us, and so here you can see the set, right? So we've got Petit Syrah, Zinfandel, Cabernet Franc, Pinot Noir, and so on and so forth. And so this, this is where we've actually gone through the trouble reasoning about all this stuff. And some of these aren't directly red wines. They inherit it through, so for example, like Saint-Emilion is in the Burgundy region and is a subclass of, or maybe actually, yeah, maybe that one is red. But some of these others, for example, derive, so like you could have, I think Meritage, derives from something, it might derive from like red table wine, which actually is red, and then you get it that way. More complicated one, we could go in and go back to our index, which of course, because Pellet will want to reason about it every time, for some reason the incremental thing doesn't quite seem to be working in our setup here, but that's all right. We will get our form, and then we can pick an actual grape and see that way.
So was that just an iteration over the transitive closure? Because it went like through,
Yeah,
like it
right,
went through
so-
iterations.
Yeah, so if we, let's, black on black is not good.
No, it's, and actually the light, I'm having a little trouble seeing it from up
Yeah.
here.
Oh.
The projector's getting a little.
No, I think that's my fault. Hold on a second.
I was thinking that I missed you. I didn't see it.
Oh, that better?
Yeah.
All right, that's fine.
Wow. Yeah.
That's right, you changed your.
Yeah, my screen changes its
Glad I said something. I should have said
red
earlier.
values as it gets more nighttime, so I don't keep a lot of blue light in my eyes. Okay, sorry about
We
that.
almost got a
by
new
half.
projector.
Yeah, I was falling asleep.
That's good. It means it works.
Also, that's what the code looks like. Okay.
Well, everyone has a copy too.
No, I know.
But yeah, so the reason why it goes through that 4 times is because of, for example, the code in here. So we list the superclasses. So that causes it to do this classifying step, right? And then further on, we do another one of these list operations. Let me see. Or maybe not in that one, but so in this method we do list superclasses again, and then it goes through again. Ideally what it should be doing is we haven't changed the model, so it shouldn't have to classify again. Although the other thing is we're doing it in one specific class. Well, no, yeah. It's the same class, so in theory it shouldn't have to do any additional work. We could get around that by caching the results of this ourselves, rather than relying on the model to do it. Maybe there's some setting I'm missing, which is why it's not working.
So I'm not sure you answered this. I've just been thinking about the projector. Because, so was it iterating 4 times to do the transitive closure, or why was it going through 4 times?
So my point was this shouldn't be. It's going through 4 times, but in reality, we set this option where we want to do incremental classification. We've already classified this class once in that first call, and now we call it again. In theory, it shouldn't do that
Right.
another time, but it does. Right. So my point is that I agree with you that it shouldn't be doing that 4 times.
Oh, I didn't say it shouldn't be. I was trying to say what it was doing.
Oh yeah, so it's doing that 4 times because we do 4 of these superclass calls, but
Okay.
But even though we're doing this 4 times, in theory the results are the same every
Yeah,
time.
right.
We haven't changed the model, ergo it shouldn't do it.
Okay, got it. So now we're in sync.
Okay, good.
Thank you. And now we can see.
Yeah. So that's the idea there. We make multiple of these calls. it does that reasoning step multiple times. Unfortunately, again, we can personally take care of this, right? We could just say, have a little helper which would, you know, if we call for this, it would do it, and then it would cache it. And that would actually, you know, increase the performance, obviously. It's not clear why, because we did, you know, set that. This is still black on black, by the way. That doesn't help at all. Domain model. Let's pop that open again. We, when we do the initialization, right? I tried to set a number of these, right? So use incremental consistency. You know, once it's set at once, it shouldn't have to reclassify and all that stuff. So we'll leave it as it is. It works for this. Obviously, in the production system, you'd want to have it not do this 4 times. You'd want it to just do it once to save on CPU cycles, and also to just make it appear faster to your end user. But that's how it is. So that is basically everything. Does anybody have any further questions, either on stuff that the reasoner seems to be doing multiple times, or anything else?
Okay, then we'll pass out the quizzes.
Summarize where we are right now.
So where we are. So we've built a little servlet that you could, in theory, take and deploy in any of the servlet engines we happen, servlet 3.0 engines we happen to be running in our lab right now. It would allow you to provide an interface where you could give select boxes to allow people to actually choose property value pairs from your ontology. I mean, we've used the one ontology here, but you wouldn't have to just use the one ontology. You could go and change those URIs and point it to a different ontology. Maybe you want pointed to any of the, like the metadata catalog at logd, for example, right? And then use that to actually go back and do some inferencing based on the ontology, right? So the richer your OWL ontology is, kind of the more intelligent this looks. If it was just a simple Sparkle query, then you could just, you know, for example, hit Virtuoso through something like this. But here we're actually performing, you know, a subsumption reasoning in that subsumption step, right? So we get some properties, we generate an intersection which basically describes a class of objects based on the user's input, and then find subclasses of that class that we could then, you know, use to build an additional interface. Here I haven't done it for the sake of the fact that we have about an hour to talk about it. But the idea there is that when we get that set back, maybe you could say, well, here are here are line classes that are, you know, relevant to your choices. You know, do you want to pick one of these, or do you want to drill down further? You know, so maybe you could add an additional interface where you've kind of fixed those 2 properties here, and then you add another field where you ask for additional information. Maybe you say, okay, well, do you want a sweet wine or a dry wine?
So, as an example, you could use this. You could have an ontology, a pretty rich ontology, that describes a variety of different kinds of scientific data sets or scientific objects. And then you could use this to, based on user interaction, you could use this to construct a, say, a metadata template that was sort of tuned to these aspects, and then solicit from the user certain instance data, which then could get persisted in a graph to represent that particular data set or whatever it is.
Right, yeah, so, you know, we're just sending the instances back right now, but you could, you know, Jenna has a feature where you can list all the properties of those instances. And so basically be doing this, like a describe query on each of those URIs that come back.
Right,
and
well,
then that you can use to populate your persistent.
Right, yeah, so but what's of interest to me is that we're not using it to, what I'm describing is a situation where we wouldn't be using it as an object selector. we'd be using it as sort of a class selector,
Right.
which we would then ultimately, when we got everything fine-tuned based on this ontology, fill out the instance data, save it, you've got it.
Exactly.
Not that I'm hinting at anything to certain people.
Yeah, so I guess one thing, and I'll put myself on the spot here because I haven't actually tested this, but we could say list instances, and for convenience, I'm just going to change this to resource. Oops. That's fine. Now we'll skip this bit. No, I'll check that.
Everybody should be forced to code in
real
front of an
time. Yeah,
audience.
right.
You know, that's what a great test.
Yeah, no. The last talk I did this too, right? Where we were doing the reasoning using Jenna rules, and we started just like hacking random rules together.
Yeah.
So let's see. So we got Subsume now,
We made Eric do this too with his SOS stuff.
and then we got just for educational purposes. You shouldn't just change your API randomly like this. Not a good plan.
It's even better when it's a production system. When you're doing it.
Yeah.
Resource. Oh, I guess I will have to leave this in. I can just modify it slightly. And I will just say response dot next. All right, so basically, let me explain what I'm doing here. So instead of listing the subclasses, I'm listing the instances of the class now. Then I'm just basically using, because this returns an iterator, so I'm basically using that iterator to populate a set, and then I'm going to return that set. And then in the servlet, now, this is going to have to change to resource, which is actually more generic, so it will, you could, in theory, use both, because both onClass and individual and onProperty as well all derive from this resource object, so it's a bit more flexible this way. And then, let's say we do, we'll just do red lines for now, and then maybe we can go and do a grade and just see up, yeah, there we go. Resource cannot be resolved to expect. We can solve that. Maybe it didn't rebuild, hold on. I will,
Thanks to Jenna, each collapse is going to live forever.
let's just stop that. Yeah, it did say I need to restart it, okay. Try it again.
Jenna, I'll take you.
Well, it's in Apache now, so.
Probably will, yeah.
Probably will.
It's in what?
It's part of Jenna.
Yeah, Jenna.
I mean, Apache.
Jenna's part of
Apache, okay, yeah.
Software Foundation.
Yeah, so the company which
All
killed the project is going to probably, no.
So that didn't work the way I
outlive
expected.
the project.
That's okay.
So, all right.
Oh, that's, never mind. That's expected behavior because the instances are no longer in the ontology. The instances are now in a separate file. But we could, load said file. I separated out irrelevant instances simply because we're trying to do this restaurant-based thing, and not all restaurants have the same set of lines, so it doesn't make sense for them to be in the main ontology. It makes sense for them to be elsewhere. So basically, I'm just going to read in a wine list from one of the restaurant files we have and see what happens. So I'll just stop that and restart. There we go. So apparently right now we only have one red in this wine list. That's okay. Old red, Cristal, Faustino, Pinot Noir. That's the general idea, right? So if you had knowledge and instance based, like if you took all the stuff we have on log D and tried to do this type of thing, one, it would take a long time, but the other is that you would get potentially many of these results, which you could then either present in a list, or if you had some other mechanism of rendering, like if you use log speaker, for example, and you wanted to have these views over them, then you could.
Right.
So this, you could use this as a way, if they specified a lot of, property value type of things, to build up an actual class and reason about it and find those things. Depending on how complicated it is, in a very flat ontology, you can probably just do a Sparkle query and it would be faster, right? This is only kind of really relevant if you have a lot of rich kind of logical descriptions of classes that you can actually take advantage of. Right, so the stuff we're kind of doing here, for the most part, you can probably implement in a Sparkle 1.1 query without too much difficulty. You'd have to kind of simulate some of the reasoning by crawling like the subclass hierarchy and looking for restrictions and stuff like that, so the query would be pretty hairy. But you still could do it. But once you get into really complicated things where you're reasoning about, say I have a class that has all values from wine color, and then I have another class which has color red, you can infer that all instances of the second class are actually members of the first class, because you'd have to have that it has a max cardinality restriction of 1 there for that to actually work. But you can see how that would happen. And that you couldn't really do with the Sparkle. Right? So anything outside of like OWL2QL, you probably wouldn't want to do in a Sparkle query, and that's where using something like Pellet comes useful.
Right.
Okay.
So that's it?
Yes, that's a little lot of hacking at the end.
The wine.tld file, can we look at that again?
Sure.
So I understand you specified a Java class, tag dash class.
Yes.
What are the attributes for?
So, so attributes actually tell the system that these things should be expected on the field. So if I were to take these out, you would see Eclipse complain that they're not defined on the tag, and actually the handler, I believe, would balk at it, but I'm not entirely sure. It might
Also,
not.
name, class, and property are used in the HTML generation on the server side.
Yeah. So if we open up the property picker,
Yeah.
right, the first thing I do, well, I've defined the fields that's going to hold that content, and then when the JSP engine is executing the servlet page, when it encounters that tag, it will call these 3 methods, with the respected, attribute, right? So when it encounters the name attribute, it will call setName, give it the string. When it encounters the class attribute, it will call setClass.
What calls that?
The container does. The tool executing the Java servlet.
Which we don't see.
No. Well, I mean, we could probably if we really wanted to try.
So it's part of the Tomcat
Yes.
servlet
Yes.
class.
And each servlet container will probably have its own implementation of a servlet page executor. So, and at least what Tomcat does is it actually it takes your page. This is, probably more detail than anybody ever needs to know about servlets. But it will take this page and it actually it parses this, turns it into a Java class, and compiles it at runtime. So this turns into a lot of print lns essentially, and this turns into an actual call in Java to a Java class. So the idea is that the first time through it's actually a little bit slow because it has to compile the whole thing. But once it compiles, it's all Java code, which can be executed on the virtual machine and take advantage of, for example, if you're using the hotspot virtual machine, it can take advantage of the just-in-time compiler and all those other features of the Java virtual machine that you might not get if you're just interpreting this, like if you read this in and then tried to do like a regex or whatever to find that. So.
Okay, it's because we're referencing those identifiers here that you need to do that in this.
Yes.
In the index.
Right.
Okay.
Yeah.
That's the connection.
I mean,
okay.
In theory, it would be nice if they would just look at this and say, well, name, let me look for property name. But one of the things you can do is you can actually, we just use strings, but you can actually provide like Java expressions, and it will evaluate the expression before passing it to the servlet, to the tag. So you could maybe change one of these to be like an integer, and then in your thing you could do like 7 plus 9, and then inside here you would get 16. Right? You wouldn't get the string 7 plus 9, but you'd actually get what it evaluated to. So you can use that to pass around whole Java objects, for example. So rather than passing around strings, you pass around an instance of a Java model even, and reuse that in all of your tags. That gets really complicated, so it's just for tutorial purposes, it's easy enough to do strings, so I'm going to leave it as strings.
All right. Anybody else? So it's here forever. Thank you very much.